In this video, we're going to talk about what the slope of a line is and how to find it, because eventually we're trying to get to slope-intercept form, which is one of our very common forms in which to graph lines. So the slope of a line is essentially how steep the line is. So the larger the slope, the steeper the line. You can have a slope of 0 or an undefined slope or a negative slope, and we're going to talk about all of those. But it's important that you do understand how to find slope and what it is. So we're looking at slope as a fraction, and we do keep it as a fraction, not as a decimal. How many units the line rises or falls, based on if it's positive or negative, over how many units the line goes left or right. So you might quite often see this written as rise over run, and you'll hear me say it over and over because the top number tells you how many up or down, rises or falls, and the bottom number tells you left or right, which would be how you would run. To calculate slope, we're going to use the slope formula, which we're going to practice in a little bit. So let's take a look at the slope of a line. When the slope of a line is positive, the line slants upward from left to right. So we can see as I'm reading a book from left to right, it's positive. When the slope of the line is 0, the line is horizontal. So this would be a 0 slope. When the slope of the line is negative, obviously it points down as we go from left to right. And the last one is undefined, and that's a line that is straight up and down or vertical. So this is undefined slope. So let's take a look. Obviously we can see that this line happens to be a negative slope. So if I get done and I end up with a positive slope, I've done something wrong. This line is pointing down as we go from left to right. I'm going to use the slope formula, which I have recopied for you here. And remember, the slope formula just says we're trying to find the rise, which is how far did it go up and down, which is why we're taking y2 minus y1. We're finding the difference in the y values because y is the up and down line. And then the bottom is run. Run is the change from left to right, and that's why we would subtract the x values, because that would say how much did it change left to right. So just as we did with the distance formula, it's totally okay for you to label that this is my first x, and this is my first y, and this is my second x, and this is my, oops, where did 0 come from? This is my second y. And so I'm just going to use my slope formula and plug those numbers in. y2 is 0, y1 is 2, over x2 is 3, minus x1 is 0. And I get negative 2 over positive 3, and that's my slope, is negative 2/3. Now I want to make sure we really understand slope because we're going to use it so much. What negative 2/3 tells me is I can take any point on my line and I could go down 2 units and to the right 3 units, and there should be another point. Or, because negative 2/3 is the same as 2 over negative 3, I could go positive 2 units, but then 1, 2, 3 to the left, and there would be another point on my line. So I can do it in either direction from any point. So if I wanted to keep going, I would go down 2, to the right 3, there would be another point on the line. You get the idea. A lot of people have the question, what if I would have labeled them differently? So what if I would have taken 2 minus 0, and then 0 minus 3? Notice I'm going to get 2 over negative 3, which we already talked about is the exact same slope. So it doesn't matter the order that you do them in, as long as you know which one comes first, which one comes second. All right, here are a couple of practice for us to do together. Again, I've recopied that slope formula for you, so that's all we're going to do is just use the slope formula. I'm always going to use the second one as y2. If you want to do it in the opposite way, just to check my work, feel free. So the second y is 2, and the first y is negative 1. So again, be very careful when subtracting a negative. That's why I always put them in parentheses to remind myself. And then my second x is 7 and my first x is 1. So I get 2 minus negative 1, which is 2 plus 1, or 3. 7 minus 1 is 6. And I'm not going to turn that into 0.5. I'm going to leave it 1/2 because we want our slope to be a fraction. If I look at my second example, I have y2, which is negative 5, minus y1, which is positive 5, over x2, which is 4, minus x1, which is 4. My numerator, again, it's negative 5 minus 5, so it's really plus negative. So that's negative 10 on the top. 4 minus 4 is 0. And we know that we cannot have a fraction that's divided by 0 because that's an undefined. And so we know that this would also be an undefined slope. Remember, undefined slope was that one that went straight up and down, the vertical line. And you could certainly plot those points and see that those would both be in the same vertical line. Two similar ones for you to try on your own. So press pause, try both questions, then press play to see how you did. All right, let's take a look. M equals, again, I'm going to use them just in the order that they are, x1, y1, x2, y2. So this would be 2 minus negative 1 over negative 3 minus 6. 2 minus negative 1 is 3. Negative 3 minus 6 would be plus negative 6, or negative 9, which is negative 1/3. Notice I put that negative on the top. It's good for you to just get in the habit of doing that, but it is the same as 1 over negative 3. It's still the same slope. For the second one, y2 is negative 2, y1 is negative 2, x2 is negative 1 minus x1, which is 9. Negative 2 minus negative 2 is actually plus 2, or 0. Negative 1 minus 9, or plus negative 9, is negative 10. With the 0 on the top, this is actually 0 slope. And remember, 0 slope is that line that's going to look like this.